In the last video, we were discussing plausibility condition for matching problems, and we had a proposition which allowed us to prove that certain kinds of matching problems can't be solved. Of course, what we really want is to prove that certain matching problems can be solved, a kind of converse to that. So in this video, we're just going to explain one ingredient that we're going to use in that kind of constructive proof. Okay, so this is what I'm going to call the completion problem. Okay, so this is a fairly simple idea that we've kind of implicitly used already, but we just want to be a bit more explicit about it now. So we've got a matching problem, which consists of a set A of people, a set B of jobs, and a family of candidate sets CB for B and B, as we've been discussing previously. And now let's have, suppose we have a partial solution, which I'm going to call, say, M prime. So this is not assigning all the jobs, but it's only assigning some subset B prime of the jobs to distinct qualified people. So then we're going to put B double prime is the remaining jobs. Okay, so that's B with B prime removed. And then we're going to set A prime okay, so this is a subset of A, and the size of it, if each job's been assigned to one person, so the size of A prime is the same as the size of A. And A double prime is the set of still unemployed people. So that's A with A prime removed. And and then for B in this set B double prime, we define C double prime B is CB with A prime removed. So this is a set of unemployed people who are qualified for job B. Okay, we've got all the people who are qualified for B as CB, and then you throw out the ones who've already been given a job. And then now we've got a new matching problem with the set A double prime of people, set B double prime of jobs, and these candidates set C double prime B. Okay, so that's a new matching problem. That's what we call the completion problem. And of course, the point about this is that if we can solve the completion problem, then we just take the solution for the completion problem and sort of combine it with the allocations we did already for the jobs in B prime, and then that gives us a solution to the original matching problem that we started with. Okay, so key part of the proof in Hall's theorem. Right, we're going to start with a matching problem which we know is plausible, and we want to prove that it has a solution. So we're going to do some partial solution, and then we want to check that the partial solution can be extended to give a full solution. And for that, we have to look at this completion problem, and we have to check whether this completion problem also has the right plausibility condition. So that's going to be the key ingredient in Hall's theorem.